Hi everyone, welcome to today's class. Today we will talk about data wrangling. We will use about 2.5 lectures to talk about this topic. We will start with data wrangling for one table, namely one data frame. And then the next topic will be wrangling two data frames. And lastly, we'll talk about how to tidy data and how to impute missing values. So that's the outline. Okay, so let's start. So data wrangling is just a data manipulation, right? And includes the following components: subset data, sort and group data, transform data, tidy data, which means cleaning data, and merge data sets. And the goal is, of course, to get data ready for further analysis, either data visualization or modeling purpose. And we use this package, dplyr. So this one presents a grammar of data wrangling, which is designed to provide commonly used data manipulation tools and have fast performance for in-memory operations. And for more information, you can click this link and check the GitHub repo repository, which has the R code and also something else. Okay. All right. So before we start, let's take a look at tables. We have seen tables already. Tables are a special case of data frame. So in our lecture, today's lecture, we will use this data set called presidential. So this one is built in ggplot2. So as long as you load the ggplot2 library, you have access to this data set. So this one is a very small data set with 12 rows and 4 columns. Name, last name of some presidents, and start and end date of their office, and party. It's a very simple data set. If you take a closer look at the data set, you see that it is similar to a data frame, but not exactly the same. So you see it has a line says a table 12 by 4, right? So it's a table with 12 rows and 4 columns. And column names, this is regular. And then after the column name, there is a line which shows you the data type for each column, like character, date, character, etc. So this is a table. And tables are data frames that make working with big data a little easier. Right? So the table package is included in the tidyverse package. The last time I introduced you this package, tidyverse, which has 9 core packages, which is including tables. And let's see, there are 2 main differences in the usage of table versus a classic data frame. First, printing. By default, it only prints the first 10 rows and all the columns that fit on screen. So it really depends on how wide your screen is. If you have a very narrow screen, then it will only print a few columns that can fit into your current screen. And secondly, subsetting. So tables are, in addition to the dollar operator, you can also use double square brackets to subset data. For example, if we want to pull out the name column, we can do this: presidential double square bracket name. Okay? And then you have access to all of the components or elements in this column. Okay? So you see, it's kind of like a list, right? Kind of like a list. You can treat a table as a list. You can also refer to the column index. For example, double square bracket 1, you get the same result. Of course, you can also use the dollar operator to pull out the name column. What about single square bracket? You can try it. You'll see that it also works. However, the output will be slightly different with using double square brackets. It's similar to the difference about using single square bracket and double square bracket when you subset a list. So if you use single square bracket, you will slice the list. Namely, you will get a sublist from the whole list. And then let's take a look at the printing options. So you can change the default print behavior using the print option. For example, the MPG data frame has 11 columns. So by default, if you print it, it's also a table. If you print it, you may not see all of the columns, right? And for columns that cannot be shown in the screen, that it will list the column name and show some features of the column, but will not actually print the column. However, you can change the behavior using the print option. Just change this argument, let width be infinity, then it will print all of the columns. For example, you will see this. Okay, n is the number of rows you want to print. You can also control the default print behavior by setting options. Just call this function options, like table.width equals infinity. Then when you print a table, you will see all of the columns. So this is an option for table functions. And RStudio also has a built-in data viewer to view the complete data set. The view function, capital V. So let me show you. If you use this function, then you can see the data set as a spreadsheet. So first, you need to load the data set, so the library. For example, I will load the tidyverse package, which includes the package that contains the MPG data set. Okay. Then if I type view MPG, run it, you see automatically the entire data set will be shown in this upper left panel. Okay. So it will show all of the columns and all of the rows of the data set. The entire data set will be shown here. So if you want to have a big picture of the entire data set, you can use this function, view, capital V. Pay attention. And then let's move on. You can coerce a data frame to a table using the asTable function. Change the class of it. For example, the built-in dataset iris is a data frame, but you can change it to a table using the asTable function. Just apply the asTable function to iris and save the result in iris underscore TB, and then check the class. So now it's a table data frame, table, and the data frame. And sometimes you want to turn a table back to a data frame. For example, the presidential data set is a table. If you check the class, you see it's a table. And you can use as.data.frame function to change it back to a data frame. Let's save it as presidential underscore df. So then you see it's a data frame. So sometimes it's necessary to convert a data frame to a table or convert a table to a data frame because you want to merge two data frames together. It's better to let them have the exactly same data type. All right, some other good properties of tables. It never changes the type of inputs. So it never converts strings to factors automatically. And it will never create row names. And so some additional good properties. All right, now let's start to talk about data wrangling for one table. So the dplyr package provides a set of verbs for data manipulation of one data set. So actually they are 5+1 verbs. 5 basic verbs plus 1. The 5 verbs are select, filter, arrange, mutate, summarize. Select is used to select columns, and filter is used to select rows or filter rows based on some conditions. So it's specifically for used for conditional selection of rows. And then arrange is used to order the rows according to some variables or some conditions. And then mutate is used to create new variables with existing variables. And lastly, summarize. So this is used to summarize your data. Namely, it will collapse many values to a single summary. Maybe it's a one value or a few values. It really depends on the function you use in this summarize word part. So this one will change the dimension, collapse. And then there is one more verb, which is the group by verb. So this one can be used to change the scope of each function. So usually it is combined with the summarize function so that you can calculate summary statistics for grouped data for each group according to some categorical variable. And all of the verbs work similarly. Let's see. First, the first argument is always a data frame. It will take a data frame. So in terms of position, for all of these 5 verbs, the first argument is always a data frame. And then the subsequent arguments describe what to do with the data frames. It might be a list of variables. It might be a function. It really depends on which function, which verb you are using, but usually you just list them one by one, the arguments. And finally, the result is a new data frame. So this is also very important. The result is always a data frame. Even if you use the summarize function at the end and collapse data to one row or one single value, that value itself is still a data frame. It's in the format of a data frame. So this is very useful and very important. We'll see. So let's start with the first verb, select. It's used to select columns. So let's revisit the presidential data set for columns. Suppose we only want to retrieve names and party affiliations of these presidents. Then we can use the select word. So it works like this. The syntax is like this. Select the data and then list the variables you want to select. Very simple. For example, if we want to select the name and party affiliation of the president, we can just do this, right? Select. And you see the result is also a data frame or a table in this case. If originally it's a table, then the result is a table. Right? And it automatically print out the result. However, the presidential data set, the data frame, is not changed. Pay attention to that. So this is a new data frame, and you can print it out. But if you don't save it, it will be lost after you run this code. After you create And some other things related to the select verb. So it has, if you have a large number of variables, then there are a few handy options to select multiple variables at the same time. So for example, let's load the flights dataset from the NYC Flight 13 package. So this package is also very useful for us. We will use it in the next part when we talk about emerging data sets at NYC Flight 13. So you can install and load the package if you want to follow the lecture slides, run the code by yourself. And this double column means this flight data set is in this package. If you want to refer to a data set that is building a data set or a function that building in a particular package, you can use this to refer to it directly, the object directly, without loading the package. As long as you have installed the package, then you can refer a function, an object in this way. Anyway, we will use the main data set in this package, the flight data set. And so let's load the package and then use the names function to pull out all of the column names so that we can take a look at all of the columns. So it turns out that it has 19 columns. So year, month, day, departure time, scheduled departure time, etc. Like 19 columns. Suppose we want to select all variables from year to arrival time. Right? So from year to arrival time. Right? So in the data frame, they are next to each other. So they are kind of shoulder, how to say, yeah, just next to each other. They are consecutive. Right? In this case, you can use this syntax. Use colon, year colon arrive. So select flights, year colon arrive. Then all of these 7 variables will be selected. Let's see, we save the results in flight 1, and we print the first row of flight 1. Let's see, this is the result. Okay. 1, 2, 3, 4, 6, 7. Yeah, from year to arrival. And you can also deselect a few variables. For example, I want to select all variables except for these 3, year, month, and day. Then we can do this, minus parentheses, year, colon, day. So get rid of year to day. So very convenient option to deselect a few columns. So see, Flight 2 is a wide data set. If I print it without specifying the how many variables I want to print out, you see it will only print some of them, but we actually print all of them. See. Yeah, I print the first row. Okay. And then some other functions that we can use. First, to start with, ABC. So this one will select all of the columns that start with ABC. Right? So you can specify the letters you want. Right? End with is similar. End with XYZ. And a more general one contains IJK, contains 3 letters, these letters, like character string. And lastly, if the column names are similar, right? Something like X1, X2, X3 with a common character part and numeric part, it's a consecutive numeric part, then you can use this number range. For example, we want to select all of the variables with variable name and with time, ends with time. Then we can do this. Select flights ends with quote time. Right? Then we save the result in flies time 1. You got this, right? The names of it. So all of the column names end with time, right? You may also use Boolean operators to combine conditions together. So for example, you want to select all of the column names that contain time and or arrival. We use bar or. Then save the result here. You'll see the columns have either time or ARR arrival. Even this one is selected. Carrier is selected. Carrier is the airline. Right? So these are some functions that can help us to select columns with some patterns in the names. And it's good for selecting multiple columns at the same time. So we're done with select. Select is used to select columns. Then let's move on to the second word, filter. So this one is used to select rows, conditionally select rows. So the basic syntax is filter the data set and then some condition corresponding to some variables usually. Suppose we want to select observations, the presidents with Republican affiliation, party affiliation equals a Republican. Then we can do this party equals Republican. Pay attention, we use double equal. Right? So this is a condition. And then this is a result, which includes all of the Republican presidents. Similarly, we can retrieve the presidents served after 2001. Then year of start office is greater than or equal to 2001. So this year function can be used to extract the year information from a date. As you see, start is a date variable. And we can use the year function to pull out the year. Perfect. All right. So now let's talk about the conditions that we can use in the filter function. So first, we need to use comparison operators. So these are the regular ones, greater than or equal to, less than or equal to, not equal to, and equal. So all of these can be used in a logical condition. When you have two or more comparisons, you can use Boolean operators and, or not. Okay? So pay attention, these, we have learned this before, and, or. So these are for combining two vector logical values, two vectors of logical values, and double and double bar are used to connect two single logical values. So now we are combining two vector logical values. And for set comparison, we can use this membership operator. Percent in percent, x percent in percent, which is true if x is an element of the set Y. X can be a vector and Y can also be a vector. So let's see a few examples. So X is a vector with 4 values, 2, 1, 3, 0. And so see X equals 0. This comparison expression will yield 4 logical values. And not X equals 0. So this will return the opposite results. True, 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 false. From false, 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 true to true, 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 false. So negate the result. And then or, same thing. X equals 0 or X equals 1. Then we have false, true, false, false, or true. So all of these are element-wise. The number of elements we get really depends on the length of the vector, the length of x. Similarly, you see the last one. So the last example shows you how the membership operator works in R. So x in C01 or not. X has 4 elements, 2, 1, 3, 0. So it will take each element in X and check if it is in Y or not. So in this case, this is our Y vector, right? So 2 is not in it, so that false. The second element is 1, and 1 is in it, so true, right? And 3 is not in it, false. Last one is 0 is in it, true. So we have a vector of logical values, and the dimension depends on the length of the first object in this expression, x. So it will take each element of x and check if it is in Y or not. So this is different from the membership operator in Python. Attention. In Python, the membership operator only yields one logical value. So it's kind of different. All right, now let's move on to one example. Suppose we want to select the presidents who started the term before 1977 and Democratic presidents. So two conditions. And so year of start is less than 1977 and party equals Democratic. So 2 rows. And another example is we want to retrieve presidents whose party is Democratic or who started the term before 1977. So in this case, we use the vectorized or that will have more rows. Okay. So as long as one of the conditions is true, then that row will be selected. So either Democratic or before 1977. Okay. So naturally, we might need to combine the filter and the select verbs together. So for example, suppose we want to find which Democratic presidents served since Watergate, and we want to pull out the name of the president only. We don't want to have other information pointed out. So we can do this. We first take the presidential data set and use these two conditions to select rows using the filter. And then feed the result in the select verb and then select name. Now we'll get this result. And remember, all of the verbs in dplyr, all of the 5 verbs in dplyr will return a data frame. So this makes it possible because the result of filter is also a data frame, which is good for the select verb. Yeah, treat it as a new data frame. So apparently the filter verb is nested within select. So it definitely, it's okay, it works. However, you can imagine if you have multiple operations, multiple verbs that you want to mix together, for example, 4 or 5, then if you use this nesting style, then you will have very long, wide line of code. And it's very confusing too, easy to make mistake. So that's why there is an operator which is called a pipe operator, which will sort of represent this nested structure using a pipeline. So we have seen this before. It's percent greater than percent. So the order is you start with the data frame, right? And then run the pipeline from top to bottom, right? And at the same time, within each row, it will run from left to right, which makes sense, right? And after each layer, you have a new data frame. And the new data frame will be fed into the next layer, next verb. So let's take a look at the pipe operator. So this is in this package. The pipe operator comes from this package. But if we load the type_verse package, then the pipe operator will be automatically loaded. It will be available for us. Right. And let's see the basic syntax. It always starts with a data frame. So data pipe fx. So this is equivalent to f data x. So this x is whatever argument you need for x. And the data frame is pulled out first. Right? So essentially, this is f data x. Apply something on x. Right? And for more than one verb, for example, data pipe fx pipe gy. Right? Remember, it will run from top to bottom. Right? So f will be run first, will be executed first. And if you use a nested structure, then naturally fx will be within the structure. So it is the inner layer. And so fx will work first on the data set. And the result of fx will be fed to g. So that's why G is the outer layer in the nested structure, and so on. So take a look at the previous example. If we use a pipe, then we'll do the following. Take presidential, pipe, filter. So use these two conditions to select rows, and then pipe, select the name of the result of the filter. Then we get this. So this is equivalent to the following, the nested line of code. So very convenient. With only two verbs, it's not that obvious. But later on, in the next small session, you see some examples with a lot of verbs together, and then you see it has big advantage. So how to read it? You can read it in this way: take presidential, then filter Democratic presidents whose start year is greater than 1973, then select the variable name. And so read it from top to bottom. And there are some keyboard shortcuts for pipe or the pipe operator. If you use a MacBook, you use Command Shift plus M. If you use Windows system, use Control Shift M. Right? And you can try it in your R console. Right? So, all right, so this is that's it for the first small session about wrangling one table. Any questions so far? All right, now let's move on to the second small session. So we have talked about tables, and then the 5+1 verbs structure. We talked about the first two, and also the pipe operator. So now let's move on to talk about the last four. The third verb is mutate. Mutate is used to add new variables, to create new variables with existing variables. And there is an additional verb, which is rename. So this is not included in the 5 verbs, but it is sometimes useful. You can use it to change the variable name. If you don't want to use a function like transform a variable, you just want to rename a column, then you can use this verb. Yeah. So let's see. So notice that in the presidential data set, we have the start and end date of the president's office, but we don't have a variable that is used to measure the length of each president's term. We can add a new variable to measure that. We can do the following. So first, let's load some packages. Load the dplyr package and the ggplot2 package, because this one contains the presidential data set. And in addition to those two, I also loaded this package called lubridate. So this one is also built in tidyverse. It is used to deal with time and date data, lubridate. So now let's see how to add a new variable. So take presidential type and call the mutate verb and create a new variable called term length. So this one, I just name it. So you name it by yourself. And then give an expression, which is equal to end minus start divided by d years 1. Okay. So this d years 1 is the time period within 1 year. So consequently, the result will be the number of years for each president. So the term is measured in years. Okay. And this d years function is built in lubridate. That's why we need to load this package. Then let's take a look, save the result in my presidents, and then you see there is an additional column at the end, which is the term length. It's a double, it's a float, and then these are the first 3 observations. Again, by default, the presidential data set will not be changed. Even after you run this pipe, this won't be changed. If you want to save the results, save the new data frame and give it a new name. I call it my presidents. Then let's take a look at the d years function. So this function is just used to give the duration of time in X years. Right? So if you put 1 here, it will give duration of 1 year. If you type it in your R console after you load the lubridate package, you type this in your R console, you will see this. It is the number of seconds per year. Basically, it's just a measure of time, of 1 year of time. And then if you are curious how many days are in 1 year, by default using this function, it's actually 365.25 days. So it actually is not 365. It considers the lunar year. So adjust for that. All right. Change names. My president have these 5 columns. The last column is called term length. We just created a new variable term length using mutate. If you want to change name, you can use the rename function. It also take a data frame, and then you just specify the new name equals old name pair. So it's in this order. New name equals old name. Basically, it's like you assign the old variable to a new variable, somehow like that. So for example, we can take my presidents and pipe and call the rename function, and I give a new name, term dot length equals term underscore length. And then take a look at the first 3 rows. Yeah, by the way, you can call the head function in the pipe too to show a few rows. So see the last column has been changed. The column name has been changed. However, if you check the names of my presidents, it actually didn't change. Again, so only in the printout, it has been changed. But actually it isn't. It hasn't been changed. So if you want to save the result, give a new name to it. And then check the name has been changed. This is a rename function. This is an additional verb. If you only want to change the column name without doing anything else, you can just use this function. You don't have to use the mutate function. You can also use the mutate function. It will still work, but it's not necessary. And then let's take a look at some functions that can be used in the mutate function to create new variables. So these functions are called creation functions because they will create a new vector with the same length of the original vector or vectors. So you see, take a vector of values as input and return a vector with the same number of values as output. So notice that the mutate function will add new columns, right? So you need to make sure that the new column has the same length with the original vector or vectors. You cannot change the dimension. So functions that can be used to create variables are functions that will do calculation or execution element-wise. So all of the arithmetic operators work in that way, element-wise, plus, minus, multiplication, division, exponentiation. All of these will do everything element-wise, so no problem. And also the log functions, natural log, log base 2, log base 10. So namely, let's see some examples. So y is a vector of 3 elements, right? If you take log 2 of y, you have a vector of 3 elements. So it will not change the length. This is good. You can use it to create a new column. Similarly, exponential functions. So this will calculate e to the x. It will also keep the length. So you see sequence from 0 to 1, the jump is 0.3. So 4 numbers, 0, 0.3, 0.6, 0.9. So this is the entire vector. And then you take you calculate e to these numbers, right? Then you have 4 numbers too. E to the 0 is 1. So anyway, the length won't be changed. And some special operators, modular arithmetic operators. First is integer division, percent divide percent. Integer division is also called floor division. It will calculate the quotient and run it down to an integer. So for example, also the second operator is the modulus, right, or remainder. So this will yield the remainder of the division. Suppose we want to decompose the arrival delay into 2 parts, the number of hours and the number of minutes. Right? So originally it is just the number of minutes, right? The unit is minutes. Suppose we want to separate it to 2 parts. Right? We can do this. So take the flights data set, select arrival delay, and filter out positive arrival delays only. Right? Some flights arrive earlier, actually, so we filter out those. We just consider positive arrival delays. Right? Then use the mutate function to add 2 variables. The first variable is arrival delay in hours. Right? So we use floor division. Arrival delay modulus divide 60. So this will calculate the integer. Right? The integer is the number of hours and run it down to an integer. So for example, if the arrival delay is 30, right, then 30 divided by 60 is 0.5. You run it down to 0. So 0 hours. And the leftover, the remainder, which is 30, will be the number of minutes, right? So which makes sense. And the arrival delay in minutes will be the remainder. So we use this modulus division, arrival delay modulus 60, which is the remainder. Right? And save the result in a new data frame called delay. Right? And then I just want to show you some observations with arrival delay that is greater than 15 minutes. And show the first 5 rows. You see this. Check the result. For example, 51, right? 0 hour, 51 minutes, right? And for greater than 60, 123, 2 hours, 2 minutes. So this example just shows you these two special operators, integer division or floor division and remainder. And all of these are good in creating new variables using the mutate function. Right? If you change the dimension, if you use a function that will change the dimension, for example, you use the mean function in it, you will get an error because you change the length of the vector. And there are some cumulative and rolling aggregates. So these are not aggregation functions because it will not change the length. For example, z is a vector 1, 2, 3, 4, 5. The cumulative sum function will be this 1, and then 1 plus 2, 3, and then 1 plus 2 plus 3, 6. So it gradually adds one number to the sum, the current sum, the cumulative sum. And similarly, we have cumulative mean, cumulative product, minimum, and maximum. Right? So as long as the function is cumulative, it will not change the dimension. So they can be used in the mutate function, no problem. All right. And we're done with mutate and rename. Mutate is used to add new variables using existing variables. So basically, it is used for data transformation. And next verb is arrange. So this function is used to sort your data frame according to a variable or some variables. So pay attention, the sort function will sort a vector only, but not a data frame. So the sort function will sort a vector alphabetically or numerically, it's fine, but it cannot be used to sort a data frame. So to sort a data frame, we can use arrange. For example, suppose we want to sort the presidential data by term length from the longest to the shortest. We can do this. Take my presidents. So this is a data frame we created with the fifth column, which is term length. Okay. Arrange it according to term length, but in descending order. So if you want to do it in descending order, you have to add this DESC. Then this is the result. Okay. And by default, it's in ascending order, of course, from smallest to largest. All right. And again, the range function will not change the original data frame. So if you type my presidents again, it's not sorted. If you want to save the result, save it, give a name, save it. And then this my presidents one is sorted. You can also sort the result by multiple variables. For example, I want to arrange the results, the data in descending order of term length and start time, because otherwise there will be ties, right? There will be ties in it a lot. Many people have served 8 years or 4 years. So you have the option to add more variables in a range. So this is a result. It's a range. And the last one is summarize. The last function in the 5 verbs is summarize. There are 2 versions, summarize Z or summarize is S. It doesn't matter. I think they are equivalent. Originally, it was summarize with S in it. So let's see how to use this verb. So this one collapses a data frame into a single row. How many values in a row? It depends. Depends on the function or the number of variables you created in the summarized part. So we have to specify how we want to reduce an entire column of data into a single value. For example, take my presidents, my type, summarize. We can calculate a bunch of variables. N is equal to n parentheses. So this function, n parentheses, calculates the number of rows in each group of data. Because we haven't called the group by variable yet, so it will just simply calculate the number of observations in your data set, in the presidential data set, my presidential data set. So no argument is required, but you need parentheses. So this will calculate the number of rows. And then first year is a new variable, which is the minimum of the start date, year of start date. And last year is the maximum of the end date, year of end date of all of the presidents. And then number of Democratic presidents. So that will be sum of party equals Democratic. So this one will yield a vector of logical values, true or false, and the sum of them is the number of trues, so Democrats. And then total of years, which is the total term length, and then average term length. So if you take a close look at this chunk of code, you'll see that each variable will take a column or the entire data set and collapse it to one single value. Each of them, totally 6 of them. So we will create a very small data frame or a table with 6 columns and 1 row because each one will only yield 1 value. So this is the result. N is 12, first year, last year, a number of Democratic presidents, total term, and average term. Okay. So this is how the summarize verb works. Right? It will take a vector and yield 1 value. And many times the summarize verb is combined with the group by verb to change the scope. For example, in the last slide, we calculate that the average term length for all of the presidents is 5.67. Then you may be curious about comparing the average term length between the 2 parties. Which party has longer average term length? In that case, we can group the data by party first. So take my presidents group by party and then calculate some summary statistics. For example, we can still calculate the number of presidents and then average term length. At the same time, we can calculate the standard deviation of term length and then save the result. So now we have grouped summary of data. In particular, you can compare their average term length. Turns out that Republican has slightly higher average term length compared to Democratic, but very close actually. Right? And the standard deviations are also very close, 2.32 versus 2.34, and number of presidents. So that's why the group by this verb will change the scope of calculation. Basically, it will group the data first and then calculate something for each group. So party only has 2 unique values. That's why in the summary table, in the result, we have 2 rows. If there are like C categories in the grouping variable, then you will have C rows in the result. It really depends on how many categories. You can also group the data by 2 or more categorical variables. Then the number of rows in the summary table depends on the number of unique combinations of the values in the 2 or more categorical grouping variables. It really depends on. All right. And similar to mutate functions, there are some functions that we can use in the summarize word only. So only those aggregation functions can be used in the summarize function because you have to take a vector or vectors and collapse them to a single value. Otherwise, you cannot use them in the summarize. So first, the median function, quantile function, minimum, max. So all of these will take a vector and yield one single value. Quantile function, pay attention, it by default will yield 5 numbers if the 5 number summary. But if you specify which percentile you want to calculate, then it will yield one value. And also some functions related to counts. So this n parenthesis, we have seen this before, will yield the size of the current group. See, the current group, 5 and 7, will count number of rows. And n distinct x counts the number of distinct values of a variable x. So this will also take a vector and yield one single integer, which is the number of distinct values. And this one will also will count number of non-missing values. So this not is done NA will yield a vector of true or false values. So if it's missing, then false. If it's not missing, true. And then cover the sum, that will be the number of non-missing values. So, and the second, this part is counts and proportions of logical values. So I have mentioned this before. Right? In R, true is equivalent to 1 and false is equivalent to 0. Right? Somehow like this. If you have to do some calculation using true or false values, they will be treated as 1 and 0s. Right? So for example, you compare x with 5, then you have 4 true values and 6 false values, right? And then we can actually calculate the sum of them and also the mean of them. The sum of a logical vector is the number of true values, And the mean of a logical vector is the proportion of true values. Proportion of true. So we can use it to summarize logical vectors or to check some conditions. What percent of observations satisfy a certain condition, etc. Right, so we can use this property. All right. And then let's move on to the next small topic, handling missing values. So in this lecture, we will just talk about the simplest rescue, which is deleting those observations or ignoring those values. And in the last lecture, we'll talk about how to impute missing values using some packages. So in R, missing values are denoted by NA, not available, which represent an unknown value. And almost any operation involving an unknown value will also be unknown. So NA will produce NA. So missing values are contagious in R. So for example, x is a vector of 5 values and the third one is missing. Then if you add 10 to x, then the missing value will yield the missing value because R doesn't know how to handle it. It can only yield the missing value. Okay. So for this kind of math arithmetic operators, it does everything element wise. It doesn't matter that much because it will just yield one missing value. But what really causes problem is using its aggregation functions because usually it will just yield a missing value because it doesn't know how to take average of missing value and some numbers. So to avoid this problem, as we have learned before, we can add this argument na.rm equals true to ignore missing values in the calculation. Then we have a valid value. And the summary function is special, right? Summary function will automatically ignore missing values, and also it will calculate the number of missing values for you. So this is kind of a special case, right? And to filter out all observations in a data frame with missing values in a variable x, you can use this kind of syntax or code. Right? So take the data, filter, right? Not missing x. X is a particular column in it. So this will remove all of the observations in missing values with missing values in x. Okay. So alternatively, we can use the drop NA function in tidyr. So the pandas package in Python also has this function drop NA, exactly the same function. Okay. So you can take data and pipe drop NAX. So this will remove all of the observations with missing values in x. Right? So same thing. Just pay attention. These two functions is.na as not is.na and the drop na only works for real missing values. Right? That values that are actually denoted by NA. If the missing value are coded in some other ways, then they won't work. Right? Just pay attention to that. And then let's take a look at some examples. So we first create a very small table. So notice that I load the tidyr package and create a table. And so table can be created in this way. You just specify the two columns, the columns you want, okay? The 1, 2 missing, A missing B. So this missing value is denoted by like triangle parentheses NA because this is a missing value, missing character value. Okay, so this is a missing double value, but essentially they are all missing, right? You can use drop NA or is NA to remove them for sure. So let's see if we want to remove all of the observations with any missing values in any column, then you can just take the data frame and pipe drop NA without anything. Then you see the result. Only the first row is left because the second and third row both have missing values, right? If you only want to remove missing values in one variable, then specify the variable name in drop NA. For example, I only want to remove observations with missing values in x. Then we do this. Then we see the second row is retained because it still has a valid value to the x column. So this is also very useful because the situation of different column may be different. And maybe X has a few missing values only, so it's okay to remove those rows. But Y probably has a lot of missing values. Then it's not ideal to remove all of the rows. You will waste a lot of data. In that case, we probably choose to impute missing values in Y. So different strategy, but different columns. All right, great. Then let's see a few uh, extended examples in using the 5+1 verbs in dplyr to answer some data exploration questions. For example, let's use a flight data set again. So, by the way, this package has information of all flights departed from NYC in 2013. So it is quite a big data set, contains all of the flights departed from New York City in a year in 2013. So that's why it's called NYC Flights 13. It actually has 5 data sets, and the flights data set is the main data frame, main data set. Suppose we would like to know which carrier has the longest average departure delay on January 1st, 2013. So to answer this question, we will just use the verbs that we have learned. Right? Just examine the question first. Let's take a look at the columns that we need to use to answer this question. So first, carrier, which is the airline. This column is required, right? And the departure delay, right? So departure delay is required. And also a month, day, and year. So all of these are required. And yeah. So basically we need 5 columns. So that's why we first select these 5 columns. Okay? And the rest of them are not necessary. So ignore them. So take flight, type, select this. And then we will filter because we only care about flights on January 1st, right, the first day of 2013. So we will use this filter to filter the related flights, month and day. Right? And also suppose we want to consider positive departure delays only. Right? So then we add one more condition. Departure delay is greater than 0. We use AND to connect all of these conditions together. And then take a look at the question again. We want to compare average departure delay between carriers or airlines. That means the basic unit in the comparison is airline or carrier. That's why it makes sense to group the data by carrier before we summarize the result, namely calculating the average delay, right? So we first need to group by carrier and then call the summarize function. Create a new variable, which is the average departure delay, which is the mean departure delay. And pay attention, there are missing values in this column, so don't forget to specify this. So after this row, we will have a small table with on each row of which is corresponding to one airline, right? And arrival delay. And lastly, we want to know which one has the longest. So which means we should sort the result in descending order of departure delay, average departure delay. So that's why we do this last. And save the result in delay. This is the result. So this is how we answer a question using dplyr verbs. So see, we do everything in a very precise way. We didn't waste anything. We didn't select any variables that are not necessary. So this is one example. And a second example is For example, which destinations have the longest average arrival delay on December 25th, 2013? So following the same strategy, we first select the related variables. We apparently need destination. For all of the flights, uh, the departure, so there are three airports in New York City, but the destinations are very different. Right? So we need to select the ST, right? And arrival delay, apparently, and also month, day, and year. All of these are required. And filter the flights on this day, Christmas Day, and also allow delays present. And now we're comparing average arrival delay among destinations. So that's why we need to group the data by DSC, ST, now destination. And then calculate average arrival delay, arrange result in descending order of average arrival delay. Get the result. So it turns out as this. And you can see that the destination airport are denoted by their airport code. So kind of difficult to understand for some of them. So in the next lecture, we'll talk about how to add metadata to a main data frame so that we can have more understanding of data. And the last one is which carrier has the highest average speed to San Francisco? So this one involves creating new variables because in the data set, there is no speed, no variable that is used to measure the speed. We need to calculate it by ourselves. So first we select variables. We need airtime, distance, destination, and carrier. Because distance divided by airtime. Airtime is the time in air. Okay. Distance divided by time is the speed. Right? And destination should be San Francisco only. Right? And carrier is related because we are comparing among carriers. And then filter out flights with destination equals San Francisco. And then we calculate the new variable, which is the speed. So when we calculate a new variable, we need the mutate word. So speed equals distance divided by airtime times 60. That's because airtime is measured in minutes. So distance divided by airtime will be the speed in minutes. But usually we measure the speed in hour, so per hour. So multiply it by 60, that will be distance per hour. Okay. And then more missing values, and then group by carrier. So and calculate average speed, and then arrange by average speed in descending order. So UA is the fastest, okay, 450 miles per hour. And then Delta and some other airlines. From this example, you see that although it seems very straightforward, it's still very important to order these verbs. Right? You see select filter usually, and if you want to create any new variable, you need to do it before group by, actually. Right? But group by should always be before summarize. Because you want to calculate some summary statistic for each group. So group by is always above summarize. Right? And then arrange usually is the last word because you want to sort the final result according to some order so that you the result that is of interest will be on the top of your output. All right, the last slide is about side story of the dplyr package. The motivation is to imitate SQL. So all of the verbs in dplyr are similar to some command in SQL. And also when we talk about dealing with two data frames, merging data frames or join data frames, you will see something that is familiar too, in SQL too, like the different types of joins, like inner join, outer join, left join, right join. So these are also like key components in SQL. So the purpose, of course, is to manipulate data in a very efficient and effective way. All right, perfect timing. That's all for today. And tomorrow we'll talk about merging data sets.